Hi everyone, today's objective is compound inequality. To start off, we need to know the definition of compound inequality. And compound inequality's definition is two inequalities joined by either and or. And the first objective we are going to do in this section is solve compound inequality involving and. And the definition of what is and. And is a intersection for two sets of A and B, and the intersections of A and B symbolized by A intersect A. That's an upside down U, is a set containing only elements that are in both A and B, both in A and B. So an intersection procedure is to solve compound inequality involving and 1. Solve each inequality in the compound inequality. 2. The solution set will be the intersection of the individual solution sets. For example number 1, we're going to take a look at the situation. What does it mean by intersection? So intersection means if you example 1 says A equals 1, 2, 3, 4, 5. Example B is 3, 4, 5, 6, 7. When you have an and, that means it has to be in both of them. And so if it's in both of them, that's A intersect on the upside down U. And the way we're going to write it in a set notation is going to be pick the ones that's the same. So 3 is in both of them. 4 is in both of them. 5 is in both of them. We are calling that they are the intersect. It's going to be 3, 4, and 5. For example 2, there's a couple things I would like to review. 1, what is a greater than less than symbol? It's you use open circle or you use parentheses. And greater than equal to or less than equal to, it's a closed circle, and then we use brackets. I'm going to graph example number 2. So x is greater than 3, 1, 2, 3. I'm still going to use the parentheses and brackets. Open circle is going to be parentheses, and then it's going to be more than 3. And the a, so a is going to be bracket, and then it's going to be smaller. So it's going to be this way. Now, I would like you guys to take a look that make sure you label where is the number. So if you take a look at it, when we bring down the and, so which part is in both of them? If you look at it, it's going to be 3 and 8 is going to be in both graphs. That's going to be and. And the solution is going to be parenthesis F3 and bracket at 8. And that is the answer in between of them, because that's the intersection. That's what is in both lines. The first line and in the second line, they both have to combine, ended up in the third line. So in this case, write it without and. Well, what does that mean? That means I need to put this answer right here. Now, that I call that my sandwich equation inequality you have to write. Literally, it's just x in the middle or whatever the letter they want you to use. And then you put down 8 on one side and you put down 3 on the other side. Now, depends on the situation. Since 8 has a bracket, that means equal to. It's going to be less than, equal to, smaller, because it's 7, 6, 5, 4, 3. But x is going to be bigger. So in this case, it's going to be x is bigger than 3. Right here, x is bigger than 3. This one is 8. Is bigger than x. X is greater than 3. Now, because no equal sign, there's no equal sign. This is parenthesis, no equal sign. This is a bracket, that's equal sign. So now that's the first part of your answer. Writing in set notation is the same exact thing. Now, since we are using x, it's the same thing, x slash 3 less than x less than or equal to 8. You just write down whatever they have without the and the interval notation is just what is the number in between. What's going to be between 3 and 8 in brackets. Example number 3 is the typical problem we are going to get. First of all, you have to solve it, and second of all, you have to write down without and then set building notation, interval notation. Eventually, without and will also go away because you have to decide is that and or the next things we're going to talk about. So please go ahead and solve it, and let's go back and then you can come back and check your answers. For example number 3, we have to just solve basic equation by 3x minus 1 greater than, pretending that inequality sign, like an equal sign, solve it just the way it is. So minus 1 both sides, you got 3x greater than 3, and divide by 3 on both sides, x is greater than 1. And same thing here, minus 4 on both sides, and 2x less than equal to 10, and divide by 2, x is less than equal to 5. And then I graphed it. X is greater than 1, so it's on the red line. 1 right here, in parentheses going towards the right hand side because it's going to be bigger than 1. And the next one is x is less than or equal to 5. So I use bracket because I have an equal sign. And then since it's less than, I'm using the blue line and it's going towards the negative number because it's smaller than 5. Now, I colored it in orange, the box. You guys should see it's a parenthesis between 1 and bracket 5. That's in both of them. So to write that without the and is just 1 less than x and less than or equal to 5 based on the sign they have. And I just rewrite it with a x is less than or equal to x less than or equal to 5. That's a set builder notation. And interval notation is just telling me without the two, those are just the two ends. So it's going to be parenthesis at 1 and it's going to be bracket at 5. That's example number 3. Example number 4 is a little different now. So example number 4 doesn't have an and in the middle because they combine them already for you. Is we are going to think about this is a 3 different all point into 1. So we are always going to look at the middle one because the x is there. Hey, negative 3x plus 7. If I'm just solving a basic equation, I need to get the x by itself. I'm going to minus 7. Then I'm going to minus 7 to balance my inequality. So I minus negative 7 to another side of the inequality sign and to the front of the inequality sign. So therefore, I got negative 9 less than or equal to negative 3x, less than or equal to negative 6. Get x by itself, so I'm going to divide by negative 3, divide by negative 3, and divide by negative 3. Now, be careful. Hint. When you divide by a negative, you need to make sure you change the sign. So that's going to be 3, and here's changing the sign. I want to be very obvious. So the sign got switched because I divide by a negative. That sign is also going to be changed. The answer going to be x because negative 3 divided by negative 3 is 1. And then 1x is just x. And negative 6 divided by negative 3 is going to be 2. So it's greater or equal to x and it's greater than 2. And that totally makes sense. Your inequality should make sense. Your 2 should not be bigger than 5. Read your inequality symbols correctly. The graph is 3 is greater than, so you have 2 and 3. And 3 is going to be bracket because that is greater than or equal to. And the 2 is also a bracket greater than or equal to. So it's in between there, and that is the graph you should have. Now, what you're going to do with set builder notation is just write down whatever the answer that's over here, all right? And the answer I put it down is going to be in more like in order. So it's going to be x slash, and same thing right here. You can look above it. 2 is less than or equal to x is less than or equal to 3. And if you want to do the interval notation, it's going to be at 2, comma 3, just like your picture above it. And that's example number 4. Please try your example number 5. Example number 5, x is greater than and equal to negative 3, and x is greater than negative 4. So to put them in the graph, it look like this. X is greater than negative 3, x is greater than negative 4. One of them is in brackets, the other one is just in parentheses because one of them is in a inequality but without any equal sign. So that should be parentheses. This one with an equal sign should be a bracket. Now the picture will look like this, the graph. And now here's the new stuff that it's going to be a little confusing, but if you listen and if you think about your definition, when you look in the graph, where is both color lines were showed up? It starts at negative 3. They both share spots starting at -3, okay, because and has in blue lines and the red line. So that's at -3. So the answer for this question starts at -3 for and x is greater than or equal to -3 because it's in both. This is in both graph. All right. Then once you do that, you realize the answer that's in both graph, it starts at -3. So that's going to be -3 all the way up to positive infinity. Both arrow keep on going. So it's -3 is the starting point that both of them have in common all the way to positive infinity. So this is the answers for number 5. This is where it's going to get a little bit trickier. Going on example number 6, please solve it and then let's talk about the answers. For example number 6, I solved it by -3. +3 on both sides because it's a -3. Then here's the tricky part. -4x greater than 4. Because it's -4, I'm dividing. This is where I have to change the sign. The sign gets changed because you multiply, divide by a negative. The sign changes. Same thing here. You multiply and divide, right here is divide, by a negative, the sign changed. So now what we're going to do is x is less than -1, x is greater than 2. And then we're going to draw the graph. Now I'm drawing the graph by saying x is less than -1, x is less than -1, which is right here, and -1 going this way and it's parenthesis. X is greater than 2. It's in purple. And it's also parenthesis. Now the problem is since this is and right here, this is and, I need to have both lines intersect. That means they are overlapping. Now when you look at the graph, there's the red line, the purple line. None of them is going to be overlapping. So it's called empty set. That's called the empty set. There's no solution, or you can just use empty braces to represent the set notation without anything in it. And the interval notation, there's no value in the solution set, so there's no interval notation. So the graph will be like this right here. And this is what we're going to put down for set building notation because there's no solutions. All right. So that's example number 6. Now the second objective, solve compound inequality involving OR. Solving compound inequality involving OR. Definition, we call it the union. So the union is going to be for two sets A and B. The union of A and B symbolized with the upside down U. That's kind of cool. Union look like a U, and this is up. So union and regular U, and the other one's the upside down. Is a set of containing every element in A and B. So that means if it shows up once, it's counted. Shows up once, it's counted. So OR union. Procedure to solve compound inequality involving OR. Solve each inequality in the compound inequality. 2. The solution set will be the union of individual solution set. That means every one of them, it shows up part of the answer. Let's take an example number 7 so you guys have a better idea. If I have an A set, which is 1, 2, 3, 4, 5, and the B set is 3, 4, 5, 6, 7. So as long as it shows up, you get to write it down. What happens if there's repeated? We just write it once. So it's going to be 1, 2, 3, 4, 5, 6, and 7. Because as long as it shows up once, this covered, and then anything that shows up once, get to write it down. That's all is the difference. The other one is what they have overlapping. This one is as long as it shows up once, you write it down. So please solve example number 8, and then we will talk about the answers. Example number 8, I solved it, and the few things that I want to talk over with you guys is when I multiply the 2, how do you get rid of 2 over 3x? 2 over 3, you need to get rid of it. I multiply by the reciprocal. So I multiply reciprocal of 3 over 2. I have to multiply reciprocal of 3 over 2. But I have a -2. But -2 can be written as -2 over 1. And the 2 and the 2 cancel out. That's why I can have -3. Or you can say -2 times 3 is -6 divided by 2. That's still -3. And that's why I did the same thing. Then I put them on the graph. Now when you put it on the graph, -3 is going to the left, but it's bracket because it's an equal sign. 6 is to the right, but it's also bracket because it's an equal sign. Now, because this is our OR, if it shows up on either lines just once. There's no overlapping. If it shows up once, we put it down. So we are going to tell everybody the solution is x is less than or equal to -3, which is this line, or this is the line going to the right, which is x is greater than or equal to 6. Because the answer shows up once, we gotta put it down. That's how you write the answer. And for the interval notation, it's not just one parenthesis, not one set of notation anymore. Is we need to talk about the red line, which is going towards -infinity to 3, and union. There's a union that means plus, not a p, 6 right here, all the way to positive infinity. So those is how you write the interval notation. That's example number 8. Let's try example number 9. You should be able to solve it, and then we'll talk about the answers. I'm going to just really quick going through the solution on the solving. Once you solve, this x is greater than -2, x is less than or equal to 5. And once you solve that, we are going to move over and then put it on the graph. Graph, it says x is greater than -2, so the line is going to go towards the right. And then x is less than or equal to 5, which is 5 right here, it's going towards the left. Now again, remember this is a or. Because it's or, as long as the number line shows up at one time, it's going to be considered to be part of the answer. So since the purple covers this to the left and the red covers to the right, every single piece of number on the number line will be covered either by the purple or the red. So in this case, the set builder notation is every single number is going to cover by some sort of number line, all right? Because they are going to be covered by some sort of number line, x is a real number. So any number, when they put it in there, one of those equations will work. So you can say it, x is a real number, or you can just put down big huge R with a little slash through it. And the interval notation is going to be going from -infinity to positive infinity, because every single number is going to be covered by either the purple line or the red line. So all the answer will work. That will conclude today's notes for compound inequality, and thank you so much for watching.